All right, so this is the lesson that we did on Tuesday in class. It's the 2.1, what we were not able to finish on Monday. So I'm going to go ahead and finish this for those of you that were absent. I know there were a few of you that were absent on Monday. So, on Tuesday. So let's go ahead and get going on that. So on this one, we are going to be solving equations by substitution. Real quick on my screen, I'm going to put my phone in Do Not Disturb or my iPad. Sorry about that. But so we're going to be doing solving systems by substitution. So substitution sounds, you do exactly what it sounds like. You're going to substitute something in. So notice we have a variable here that has a coefficient of 1. We also have another variable here that also has a coefficient of 1. And so it doesn't matter which one we want to solve for, but we're going to solve for one of our variables to plug it in. So I honestly cannot remember which one we did with the notes if you were in class, but it doesn't really matter which variable you solve for. I'm going to go ahead and solve in the bottom equation for x. So to do that, I'm going to go ahead and add y to both sides. Let me see if I can make this skinnier. Sorry, it's been a little bit. I got to remember how to do this. Okay, so plus y to both sides. So we get that x equals y plus 3. So now that I have that solved, I can go ahead and plug it into the first equation anywhere I see an x. So I would have this y plus 3. Okay, I'm going to plug it in for x. Okay, so I would have 2 times y plus 3 plus y equals 6. Okay. And so from here, I'm just going to solve this for y, excuse me. So I'm going to go ahead and distribute. So I would get 2y plus 6 and then plus y equals 6. And so combining like terms, I get, 3y plus 6 equals 6. Again, I'm just solving this equation. If at any point that I go too fast on this video, feel free to pause it and then finish your step, and then you can go back to what I'm doing here, okay? But as I finish solving this, I'm going to subtract 6 to both sides, and I get 3y equals 0. When I divide by 3, I figured that y equals 0, okay? So I found what my y variable is equal to, so now I need to find what x is. So I'm going to take this y, where y equals 0, I'm going to plug it in to this equation. So I would have, well, x equals 0 plus 3. So x equals 3. So when you have two equations, and we're talking two-dimensional figures here, because of the two equations here, your answer is going to be as an ordered pair. So we always, again, write it as we would as if it was an ordered pair or alphabetically. So our answer would just be 3, 0. Okay? And so that would be our answer there for the first one. So on the second one over here, it's much the same, where we're going to solve it for one variable. I see that my x is already positive right here, and I have a coefficient of 1, so I'm going to go ahead and solve this equation for that. So we have that x plus 2y equals 1. And so I just subtract 2y, and I get that x equals negative 2y plus 1. So now I'm going to plug this in anywhere I see an x. Okay, I'm going to plug it in. Now, there's a negative sign, so because there's a negative, I'm going to put the parentheses and put this negative 2y plus 1. Because I will have to distribute that negative to both terms, okay? Okay, also one thing to notice is that I solve the top equation for x, and then I plug it into the second equation, okay? I haven't messed with that equation yet, so that's the one that I'm going to plug it in for, okay? All right, and so I'm going to distribute my negative, so I would get 2y minus 1 plus 3y equals 4, so I get 5y minus 1 equals 4. When I combine like terms, so then I would add 1 to both sides. 5y equals 5, so y equals 1. And again, just like I did on the last one, actually I'm going to use a different color. I'm going to take this and I'm going to plug it in there. Okay, so I would have x equals negative 2 times positive 1. I'm sorry, hold on. Oh, crap. Sorry. Times 1. There we have it. Okay, and then plus 1. So as I saw this, negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So my answer as an ordered pair would be negative 1, 1. Okay. Okay. All right, so the next process that we're going to go over is called elimination, and it is actually my favorite way of solving systems of linear equations. Okay. So when we eliminate, we're going to do what it sounds like. We're going to get rid of something. And so if you notice, right now I have two terms. Okay, they're both y's, and they're opposite signs. So that is the important thing to remember too with elimination, is that they have to be the same number. So they're both 5s, but then they have to be opposite signs. Because when we add our equations together, our two equations, we want it to go to 0. Okay, so 4x plus 3x, that gives me 7x. Negative 5y plus 5y is going to cancel to 0. And then 60 plus 10 gives me the 70. Okay, now this is why I like elimination so well, is because once you're to this point, you just solve it for, you're just going to solve it for your variable. So we find out that x equals 7. Okay, so then when we get to this point, now we are going to plug it into either equation. It doesn't matter which one. And we're going to solve it for our other variable. So I'm going to use this 7 here. I'm going to use the first equation. So I would have 4 times 7, because that's what x is. Minus 5y equals 60. Okay, well, 4 times 7 is 28. So I have 28 minus 5y equals 60. So I'm going to subtract 28 to both sides. Oh, I'm such a dork. I'm sorry. I was like, why is this not working? 70 divided by 7 is 10, not 7. Sorry. Let me fix this. Let me go back and fix this. 10. There we go. Sorry, y'all. Okay, so 4 times 10 minus 5y equals 60. 4 times 10 gives us my 40. Minus 5y equals 60. Okay, so I need to move my 40 to the other side. So I'm going to subtract 40 to both sides. And I'm going to get that negative 5y equals 20. So when I divide it by negative 5, I find that y equals negative 4. Okay, so again, we're going to write it as an ordered pair. So I would have 10 comma negative 4 as my answer. Okay. All right, so moving right along to the second one. There will be some cases whenever, like, as you see here, your numbers don't match. Okay? And when you eliminate, I should have said this probably a while ago, but when you eliminate, you always want to eliminate a variable. So even if these numbers matched right here, it wouldn't matter. Okay? We're not going to cancel numbers because that doesn't eliminate a variable for us. Okay? And that's the process here, is eliminating a variable. Now, I know if I have a positive 45 on top, I can multiply negative 15 by something to give me negative 45. Because remember, since this is a positive 45 here, I want to get a negative 45 underneath to go to 0. So I can multiply the entire equation by positive 3. Now, I like to have the fraction or the equations on top of each other just because it makes it easier. Oops, hold on. There we go. Okay, it makes it easier if I have them just right on top of each other when I'm adding them. So I get 45x minus 15y equals 120. And again, I just rewrote that so I can put them on top. Now I'm going to distribute this 3 to everything. So I get negative 45x. 3 times 4y gives me 12y. And 3 times negative 5 gives me negative 35. 3 times negative 35 gives me negative 105. Yep. Okay. So again, remember, we're adding these equations. So 45x plus negative 45x is going to cancel. And then negative 15y plus 12y gives me negative 3y. And 120 plus negative 105 gives me a positive 15. Okay. So now I'm just going to divide by negative 3 on both sides. And I get that y equals negative 5. So once you get to this point, you're going to plug in this negative 5 anywhere to any equation. It doesn't matter which one. Okay. Now the bottom equation isn't as big of numbers, so I'm going to plug it into the bottom equation before I distributed the positive 3. So I have a negative 15x plus 4 times negative 5 equals negative 35. So negative 15x minus 20 equals, oh, what am I doing? Negative 35. Add 20 to both sides. Negative 15x equals negative 15, so x equals positive 1. So our answer here would be 1 comma negative 5. Okay. Okay, now I am going to let you work these, but I am going to go ahead and write the answers down here for you, so that way when you do have them, you can go back and you can check them. But you work these on your own.
Mama, I'm hungry.
I'm actually going to work number 3 and 4 with you, or for you, so that way you can see, because this one is actually a little bit different. So on example 3, okay? Example 3, again, I prefer elimination, so that's what I'm going to use. And I see that for my x's to cancel here, I need the top to be a positive 12x. So I know I can multiply 2 by 6 to give me positive 12. So I would have 12x plus 6y equals 30. And so I add my equations. So negative 12x plus 12x is going to cancel. Negative 6y plus positive 6y can't, oh, I didn't mean to do that, but
Mama, can I have a snack?
it's going to cancel as well. But that's both terms on the same side of the equal sign. So that means I have to have a 0 as a placeholder. And then 27 plus 30 gives me 57. Now 0 does not equal 57. So because that's not a true statement, this answer would be no solution. Okay.
Can I please have
Okay. So again, because it is not a true statement, it would be no solution. All right, moving right along down here to the bottom one. This time I'm going to eliminate y just so you can see that, yes, you can do that. It doesn't matter which variable you want to eliminate. So I have a negative 2y right here. So I need a positive 2y on the bottom. So I need to multiply y by 2. Okay. So just rewriting my top equation. Okay, and then I'm going to distribute my 2 times negative 4 to get negative 8x. 2 times y gives me positive 2y. And 2 times 2 gives me 4. Okay. Again, remember we're adding these equations. Well, 8x plus negative 8x is going to cancel to 0. Negative 2y plus positive 2y is going to cancel to 0. But I need a placeholder on that side. And then negative 4 plus 4 cancels to 0. Now, 0 does equal 0, but so because that's a true statement, that means this answer would be infinite solutions. Okay. Now, say that you were to solve this, obviously not this example necessarily, but say you were to solve another example and you might get something crazy like 120 equals 120. Well, 120 always equals 120. So because that's always true, it would also be infinite solutions. Okay. All right. Last page. So on example 5, we have a word problem, and I know people tend to always get they kind of freak out whenever they see word problems. They think math is numbers, and so we shouldn't have words in math. Okay. But it says at a local hardware store, you notice a customer buys 12 screws, 3 hinges for $12, and you buy 16 screws for $4. So we do need to write equations here. So I'm going to make my variables pretty obvious. I'm going to use S for screws and H for hinges. Okay. So my first equation would be 12S plus 3H equals 12. And then my second equation, I have 16 screws. So 16S equals 4. Okay. So on this one, since I only have one variable in my second equation, I'm going to have to do substitution. So I'm going to go ahead and solve it for S. So I'm going to divide both sides by 16. And I get that S is equal to 1/4. Okay. So now that I know that S is equal to 1/4, I'm going to plug that into my first equation. And I'm going to say 12 times 0.25 plus 3H equals 12. Okay, well 12 times 1/4 is $3. So 3 plus 3H equals 12. Subtract 3 to both sides, and we get that 3H equals 9, so the hinges must have been $3 a piece. Okay. So on the next part, it said if 3 hinges were $7.20, what would the price be if 12 screws and 3 hinges still equal $12? So I would still have 12S plus 3H equals 12. So because we have 3H equals this here, I can plug 720 already in for 3H. Okay? So I would say, okay, well, 12S plus 720 equals 12. Okay, and just solve this equation for S. So we get 12S equals $4.80. Divide by 12, divide by 12. So that means that the screws are now 48 cents. No, 40 cents, excuse me. Okay. Okay, I'm just going to set up example 6. And I'll let you solve it, and then I'll have the answer also on here too, so you know what it is. One thing to know when you're writing these equations, sometimes kids don't know what goes with what. Well, on this one, we have some red and blue cards that are randomly in a bag. Okay, the red cards are worth $5. Blue cards are worth $34. Wants to know how many of each card could there be if there were 18 cards that are worth $293. So one thing that you have to make sure that you do, you've got to keep your money all together in the same equation. So what I mean by that is we would say, well, 5R, because I still need to consider that, or, take into account that the red cards are $5. So I'm going to have to put the R there. And then I'm going to have plus 34B. And it's going to equal this 293. Okay? So then also, I know I have 18 cards. And the only options they have is to be either red or blue. So I know that I have those equations. Okay? So you can do substitution or elimination here. It's completely up to you, whichever one. I'm not going to go through and solve this one for you. But I will go ahead and tell you, once you've solved it, you will find that red is equal to 11 as blue is equal to 7. Okay? Now, excuse me, that was all of 2.1. So, on the kind of, calendar kind of thing that I gave you, you do have 2.1 homework, high school homework, 2.1 high school homework. It is the odds only. So if you, for some reason, do not already have that, make sure that you get it out of the correct little basket thing or folder thing whenever you get back to class. That way you have that, because that is due on the 19th, which is Friday. And I know some of you may or may not be going on the attendance field trip, but that is going on this 6 weeks. So you need to make sure that you get that turned in on time. If you have any questions, feel free to email me, come see me, whatever you need to do to make sure you get this ironed out. I don't want anybody to think that they're just thrown to the fire to figure it out themselves. So please feel free to come by my room at any point. Check with me first to make sure I'm in there, because I do know 8th period I don't have a class, so sometimes I'm not in there 8th period. And then also 6th and 9th period I'm in the gym for athletics, and I am unavailable to answer any questions during that time. So like I said, if you have any questions, feel free to reach out. If not, have a great night.